Hey guys, it's Multi-Tutor Man and I'm back with another How to Computer tutorial. And for this tutorial, I'm going to be starting a brand new series. It's how to program. Alright, so first question, how does a computer work? So computers, they're actually pretty simple machines. They're not as complicated as people think. They work in very simple ways, but what they do, it's incredible. So computers, they work through electrical signals and through the exchange of data and through communication. So everything in the computer, they talk to each other. They exchange like electrical signals, which represent the bits and pieces of data. And so we're going to get to this, like how exactly, because the computers, they talk through these electrical signals, and soon we're going to get into how exactly the computer can send each other data just through these little electrical impulses. So how do computers think? So the way how it transfers data through itself is through a language called binary. Really, it's a base number system, and it's called the base 2 number system. And we'll get to the base number systems in the next slide. But first, let me just talk a bit about binary. So you and I, we speak human languages. We speak languages like perhaps English, French, Spanish, things like that. The computer, it doesn't know English, French, or Spanish. It only knows one language by default, and that is binary. How the computer learned binary, it will all make sense after I'm done teaching you the number systems. And so let's get right to that. Okay, so review of number systems. So you might have learned this in elementary school. Actually, most likely you did. And if you didn't, or if you can't remember, then I'm just gonna go through a quick review. So basically, the number systems, it's basically a range of numbers. So for example, base 10 number system, the one we use, so it's our numbers from 0 to 9 and everything in between. So that's the number system we use. That's the base 10. We go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It stops at 9. It doesn't stop it's not from 1 to 10. No, it's from 0 to 9. From 0 to 9, those are 10 numbers. Okay? The number 10 is not a part of the base 10 number system. It is from 0 to 9. That is the range. The number 10 you can make with numbers from the base 10 number system, however, and we'll get to that right after this slide. And so here's some other number systems we have. For example, here the base 9 number system from 0 to 8, and this one is an actual number system that's used quite often. The base 8 number system, otherwise known as octal. So from 0 to 7, and this is the one the computers work with, base 2 number system. So from 0 to 1, and this one computers usually programmers oftentimes use this, and computers will sometimes display data to the programmers in this number system for base 16. So from 0 to F. And I know that doesn't make much sense right now, and I'm going to explain that in the next slide. So base 16. So base 16, you see, it goes from 0 to 9, and like I mentioned earlier with the base 10 number system, it goes from 0 to 9, and it doesn't go further than 9 because there's only 10 numbers. In the base 16, however, as you can see, there is 16 numbers from 0 to 15. That is 16, and so past 9. We can't change this A to 10. No, it has to be an A. Otherwise, there could be possible confusion, because if you write, let's say you wanted to write the number 12, you would have to write a 10 and a 2, and that wouldn't make much sense if you wrote a 10 and a 2, because people would think, wait a second, isn't that number actually 102? And that's where the confusion comes in, and so they just replaced it with a single letter. Anything past 9 is a letter in the base 16 number system, but that's not what we're going to be working with, because computers, they work with binary. So moving on. So how the number systems work. So I'm pretty sure if you did do the number systems in elementary, then you've seen this before. So how number systems work. Number systems, they're separated into their respective places. So we take the number 2100, for instance. This number is in base 10. Okay, so it's a number you and I use all the time. Base 10 to the number 2100. And so this here 0, this 0 is in the ones place. This here 0, this 0 is in the tens place. This 1 is in the 100s place. Or not, excuse me, that's not supposed to be 100. That's in the hundreds place. Ignore that 1. Oh wait, yeah, okay. Yeah, this is in the hundreds place, and this 2 is in thousands place, so ignore that 1 once again. This is in the thousands place. Okay, and so all the number systems, they have something in common. They do have these places, but not all of them have tens, or ones, or hundreds or a thousands place. They have all the number systems. However, they do have a ones place, and that is the first number. The first number for any number system is always the ones place, and after that, it depends on the number system. So here we see an example of how all the number systems work. So 10 to the power of 0 is 1. That's how we figure out that this number here is at the ones place. Okay, so the first number is the base of the number. So in this case, this number is base 10. So we're working with a base 10 number system, the same number we always work with in our day-to-day lives, and it is in the ones. It's in the ones place. So that's 10 to the power of 0, which gives you 1. So that's why the first number is always 1. So imagine we were working with perhaps binary. This would be 2 instead of 10 because we're working with that number system, so it's base 2. And then 2 to the power of 0 is also 1 because any number to the power of 0 will be 1 no matter what. Okay, and then the next place is 10 to the 1. So 10 to the power of 1 is 10, and that's where we get our tens place. 10 to the power of 2 is 100, and that's where we get our 100s place. 10 to the power of 3 is 1000, and that's where we get our 1000s place. And this would be the same story. This would be the same case if I kept going. So imagine there was another number right there after the 2000. It'd be 10 to the power of 4. That would give us 10,000. Okay, and this empty spot here would be the 10,000s place. Okay, so yeah, I mentioned earlier, 10 to the power of 1 is 0, 10 to the power of 1 is 10, 10 to the power of 2 is 100, and 10 to the power of 3 is 1000. And you can do all that in a calculator and it will give you those answers exactly. Okay. Okay, so going back to this slide, you noticed here that maybe you noticed this in elementary school, maybe you just noticed this now, but if you multiply the number and its position, then you will eventually get the exact same number. So the 0, if we go back, was at the ones place, and the other 0 was at the tens place. So 10 to the power of 0, which is 1, so 1 times 0 gives us 0, plus the 0 at the tens place, which is 10 to the power of 1, so that gives us 10 again, would also give us 0 again. And then after that we get on to the 100s place. So the 1 here was in the 100s place over here. So 10 to the power of 2 is 100. So we know that the 1 was at the 100s place from here. Okay, yeah, it's in the 100s place. And this would give us 100. Okay, and then our 2 was in the 1000s place, or the so this position here. So it'd be 10 to the power of 3, that would be its position, so the 1000s, so 1000 times 2. So these two, 0 plus 0 is 0, 100 plus 2000 plus 0 gives us 2100. And you see how all that worked out. All we did, we multiplied the place of the number with the number. So 1 times 0 gave us 0, 10 times 0 gave us 0, 100 times 1 gave us 100, 2000 times 2 gave us 1000 times 2 gave us 2000, and then 2000 plus 100 plus 0 gave us 2100. And that's how the number systems work. All number systems, they work exactly like that. Okay. And so now we're going to take a look at a different base system, and this is going to be the base 8 system. So the octal, the octal system, I mentioned it earlier. Here, the base 8. So all the numbers from 0 to 7, that's a part of the octal system. Okay. And so let's take a look at the number 4064. Now make sure this is not a decimal number. This is not a base 10 number. This is a base 8 number, so an octal number. And so I'm just going to tell you that right now. This number in decimal, in base 10, is 2100, as you can see here. And I'm going to show you how we did this right now. Okay, so here we break down the number 4068, and we see, so like I mentioned earlier, you take the base of the number and then you insert the exponent of that number. It starts off as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So it goes from 0 all the way, it starts at 0 and goes all the way to infinity, basically. And so 8 to the power of 0, once again, is 1, like I mentioned earlier. No matter the base, the first number will always be in the ones place, because any number to the power of 0 will give you 1. Okay, and then 8 to the power of 1, that gives us the 8th place. 8 to the power of 2, that gives us the 64th place. And 8 to the power of 3, that gives us the 512th place. Okay, so you notice how the places there are significantly smaller from the base 10 number system, except for the ones place. So this in the base 10 number system, this would be the tens place, this would be the 100th place, this would be the 1000th place. And so you notice how, because we reduced the size of our base, the size of our places also reduced, which is why our number seems to be bigger than our base 10 number. Okay, and yeah, so we go back and we see in this example here, I multiplied all the numbers with their places in order to get the final result, and so I'm going to do the same thing here. And so the ones place times 4, so 4 is in the ones place, that's why we're multiplying it by 1, gives us 4. Okay, and then we go to the 8th place, so 8 times 6, okay, and then we go to the 64th place, and then that gives us yeah, so we go to the 64th place, and there's 0 in there, so we multiply it by 0. 64 times 0, okay, and that gives us 0. And so then we go to the 512th place, and there's a 4 in it, so then we're gonna do 512 times 4, and then we add all that up. You add all that up, and you will get 2100. And so you're probably wondering how we got 2100, even though in our previous example, when we added all the numbers together after multiplying them with their place, we got 2100. We got the same number we started off with. When you do this here, when you multiply every number with their place, you will end up with the decimal number. So let's say we actually started off with, say, a base 6 number, and we did this same process here. Okay, we would end up with the decimal number. This is how you convert any number to base 10.